So you should take out the practice test that you took on Wednesday or Thursday, I mean, and if it's not done, hopefully it is, but if not, you can finish it while we go through here. I was going to do a little check and see if you were done, but I'm not here today, so you lucked out if you didn't finish it. However, I am going to collect it tomorrow before the test, so everybody should be done. Everybody should get 100% because we are going to go through this together. And hopefully you've realized that the other practice tests, how similar they are to the actual test. So you pay attention today as we go through this. You should have a colored pencil. If you didn't grab one, they're up usually on the front desk or the front table. So take out your practice test, open it up, and we're going to correct as we go. You can score it as you go. I'll tell you how many points I would give for each problem, and I would tell you how I'd score it. So you're just going to sit back, relax, and correct your own practice test. So the first question, how do you know by looking at a quadratic equation whether the parabola will be wider or narrower than the parent function? First thing to understand is what we mean when we say the parent function. I'm going to scoot this screen over a little bit. So when we talk about the parent function, that is that standard y equals 1x squared. And b is 0 and c is 0, and it's of average width. It opens up, and it's what we call the parent function. And putting numbers in front of the x squared change the graph, adding them on changes the graph. And my question is, how do you know when you look at a quadratic function, like say y equals 5x squared plus 2x plus 3, how do you know if it's going to be wider, narrower, or the same width as this parent function? And remember, it's this lead number out front that tells us that. So we look at A. But that's not enough. What conclusions do we draw when we look at A? If A is bigger than 1, technically an absolute value, but let's just ignore the sign that's out front, because remember, putting a negative out front of here actually just flips the parabola over. It doesn't have any impact on anything else, its width or its height or anything. It simply flips it over. So we're going to look at A, and when I say if A is bigger than what it is on the parent function, which is 1, so if A is bigger than 1, what will happen to it? Well, remember, this is a function that defines y values, and y is this up-down direction or height. And so when you stretch something to, in this case, 5 times its height, like if you picture a piece of gum or something, it's going to get narrow. So if A is bigger than 1, it will get narrower. If I squish it down and make it less than 1, like a fraction, like a third or a fourth or a tenth, then what happens is I'm squeezing those y's down and it makes the graph wider. Letter B, and that would be worth 2 points actually. If you just say look at A, I'm only going to give you 1 point. Or if you say the A tells you, you have to tell me what about the A. How do you know whether the parabola opens up or down? And again, that lead number tells us about that as well. So don't say if it, say if A is positive, if it leads in a positive, we know it's going to open up. If A is negative, we know it'll open down. So make sure you tell me on that one what you are looking at. In both of these cases, we are looking at A, and then make sure you tell me what conclusion you can make. If it's positive, it'll open up, and I don't care if you just draw this little graph right here. If it's negative, it'll open down. That would also be worth 2. How do you know if it has a vertex at 0? Remember, we like it when it has a vertex at 0. It makes it easy to graph, but it was the B term that determines kind of where the vertex lies, and we know that it's going to be at 0 if basically b is 0. But what that would mean, this little symbol here, double arrow means implies. If b is equal to 0, what that would imply is that you won't see a b term. So let's write no b term. What does that mean it looks like? It means it looks like, say, 2x squared plus 5, and there's no x term. Or maybe it looks like y equals x squared minus 2, and you'll notice that there is no x term on that one. So if the b equals 0, or basically if you don't see a b term, we know its vertex is at 0. How do you find the axis of symmetry and the vertex? Remember, this is our formula. X is equal to negative b over 2a. That gives us the axis of symmetry, and it gives us the x coordinate of our vertex. How do we get the y coordinate? To get the y coordinate, we plug the x value in to the function. Next up is a matching game. So those would be worth about 2 each. You kind of decide how you think you did. And we will ask you one of those 4 questions exactly on the test. You just don't know which one it is. So anyway, up next is a matching game. Match each graph with its function. And again, we're going to use the fact that we know what this lead number does to a graph. It makes it open up or down, and it gives it its width. So let's have a discussion here. If this is leading in 4, I know that that is one of the smiles. The other smile is this one, because both of those have a positive, and we said if it's positive, it's going to make a smile. Well, we've only got 2 of them that are making smiles. We've got B and we've got C. So one of those has to be the answer to number 2. Well, it's got to be the one that's narrower, because the 4 will outstretch it more than this half will. So for 2, the answer would be that it's this one, nice and narrow, opening up. So 2 would be C. Consequently, 5 is going to be the fatter smile, which is B. So the other 2 open down, -2, and this one has a -1. You'll notice, though, this one actually is up at a vertex of 0, 3, so you can let that help you. You can use widths to help you, because we know that 2 is going to make it narrower than the 1 did. But either way, here's my 1 through 0, 3. It's opening down, and it's narrower than letter A. So 3 is going to be D. And 4 is the leftover. This is just the parent function tipped over because of that negative. So 4 will be A. Next up, doing a little graphing here. Again, question is, does it open up or down? This one's going to open down because of that negative. That would be worth 1 point. Is it wider? Is it narrower? Or the same width as the parent function? Well, again, that negative is going to flip it over, and that 5 is going to stretch it to 5 times its height, making it quite narrow. So we're going to say narrower. And you can write those over here also down, narrower. What effect does that C term, that +2, have on the graph? Well, what it does is it takes the y's and bumps them up 2. So it will move the graph. Don't just say move 2. It will move the graph, or the parabola, or you can even say it, but it will move the graph up 2. All right, and those would each be worth 1 point. Next up, we're actually going to go graph it. So in order to graph it, remember, we need to know where its vertex is. And I'm not going to really correct your little chart here, but remember, we have to have the vertex. And you might be tempted to launch into -b over 2a, which is totally fine, but you must realize that the b term is missing, so it's 0. So this one's got a nice vertex when x is 0. It doesn't mean it's at 0, 0. Because when x is 0, y is 0 squared minus 3. So this one has a vertex of 0, -3. We'd make that worth 2 points. So go down here to 0, -3, and put a vertex there. Also, that means my axis of symmetry sitting here is at x equals 0. It's still -b over 2a if you want to use that. It's just b is 0, so that's kind of wasting time. So I go to my chart and I say, got it. I've got that vertex, and now I like to get some other points. And again, because the domain is all reals, any number can go into that. I like to use the symbol for it. Any number can go into the function, so I can technically put anything my heart desires on my table of values over here for x, but I'm just going to pick 1 because 1's such an easy number to work with. And you might say, but you said to use 0. I can't. I used it up on the vertex. So I've got to put a 1 in, and I do 1 squared minus 3, which gives me a negative 2. So I'm going to plot 1, negative 2. And maybe I want to find another one. Maybe I want to throw in a 2. Go ahead. I put in a 2 and I square it. I do 2 squared minus 3 is equal to 1. And again, I'm sticking it in here for x. So at 2, I'm at 1. Now I really don't need to put in a negative 1 and a negative 2 because I've got symmetry around that vertex. So this one's going to go to negative 2, and this one's going to go to 1. Graphically, just walk over 1 to the left, and on this one, walk over 2 to the left. And don't forget, when you draw your parabola, it's not a V. And make sure you put those arrows showing that it goes forever. The range is not all reals. This graph of this parabola will never hit this point down here. Never. It won't ever get actually below this invisible fence. And this invisible fence is where the parabola bottoms out. It's at the vertex down there. And I'm living above that. So my range would be all y values would get hit as long as they're above that fence, greater than or equal to negative 3. And that would be worth 2 points. This would be worth 1. The vertex is worth 2. Your graph over here is also worth 2. So let's move on to the next page. On the next page, it didn't turn for me. Oh, there it is. On the next page, notice what we're doing here. We've got, I'm just scrolling here to see how far down I've got to go. We've got number 10, and number 10 is really similar. You might say, you just asked this question. I sure did. But now I've got a B term going in there, and that changes the game a little bit. I still need to find that vertex. I still need that axis of symmetry, and I'm going to be asking you for some other things. So let's begin. The axis of symmetry and the x-coordinate of the vertex are negative b over twice a. Wake up out there. Keep correcting. Grab your colored pencil. Have at it. Your test tomorrow, number 10, looks just like this. I simply changed the numbers out front. So here we go. The opposite of b would be a negative 12. Twice a, 2 times 3 is a 6. What that gives me is an axis of symmetry, and write this down. I'll know if you didn't listen while you were correcting, because I'm telling you, you have to write x equals negative 2. You can't just write negative 2. I'm going to make this one worth 2 points right here because it's a line. And when you just say negative 2, I don't know, do you mean on the x or on the y, or where is that? I want where all the x's are equal to negative 2, provides me with my axis of symmetry. And on there somewhere lives my vertex. So I know the x-coordinate of my vertex is negative 2. So how do I get the y-coordinate? I go right up here and I do what it says. Y is equal to 3 times the x squared plus 12 times the x plus 4. And I want to know what happens at negative 2. And I can use my calculator or do it in my head, but I must always keep in mind our rules of order. When I do this, I do 2 squared first, which is 4. I'm going to have a negative 12 plus 4. So just don't make any arithmetic errors. So I have 12. Sorry, that'd be a negative 24. 12 times 2. Sorry. So I've got 12 down 12. 24. So I'm at negative 12 with these, and I'm going up 4 to negative 8. So I'm at negative 2, negative 8, and I go put that right here on my axis of symmetry. And once I have that vertex, I can't just draw my parabola however I want. I need another point. And the first point that we find is what we call the y-intercept. The y-intercept is where x is equal to 0. We choose that one because it's so easy to plug in. So when we go replace x with a 0, this goes to 0 and this goes to 0, and we just get 0c, and in this case 0, 4. So 0, 4 would go right here. Well, I need another point. It says, give me another point. Well, there's lots of things we could use if we would like to, but what I suggest for that other point is just use some symmetry. Technically, since I'm just asking you for one other point, you could shove any number into that equation for x, because remember our domain is all reals. But the most logical other point is to use some symmetry. Go 2 more. So you go 2 to the left, go 2 more to the left, and you'll be at negative 4, 4. That's the most logical one. But if you plugged in a 1 or a 2, since I simply just asked for one other point, I don't care what you plug in there. If you plugged in a zillion, as long as you do it right, I'd be fine with it. So next up, I am going to do the range. And again, the range isn't all reals because I'll never drop below this little line right here. I won't ever get under there. So my range lives above, my y's live above the vertex, which was at negative 8. And then we've got the word problem. Something being tossed. It's going up from an initial height of 5 and it's going to come down and hit the ground. And here's the function that will model its height at any given time. When will the balloon reach its highest point? So again, this is just code language for, hey kids, find the vertex. And we already know how to find the vertex. We do x equals, but in this case, this is standing for time. We do opposite of b over twice a, which would be negative 28. Over 2 times negative 16 will always give us a negative 32 on the bottom because that negative 16, remember, is gravity pulling on it. So we've got 28 over 32 as a fraction. We could reduce the fraction. We could go decimal. I'm just going to say it's about 0.875 or 0.88. I'm fine. Don't round it all the way to 0.9. If you did, don't mark it wrong, but we will tell you specifically on the test what to round it to. So if you wrote 0.88, or if you even went all the way to 0.9, give yourself full credit for that. That one I'd probably may worth about 3 points, but up here I forgot to do the point allotment, so let's go finish this. Your y-intercept would be worth 2. Your other point would be worth 2. Your domain would be worth 1. Your range would be worth 2. And the graph itself would be worth 2. Notice if you leave this problem blank, you are out 2, 4, 6, 8, 10, 12, 13 points. So really, really study that one if you're not sure how to do it. Now it says how high will it get? Well, I know that it maxes out at 0.88 or 0.875. How high is it going to get? Well, this tells me the height at any time. It says the height at any given time, and in our case, we're going to be plugging in 0.88 or 0.875 would be negative 16 times the time squared plus 28 times the time plus 5. And I just go put in my 0.88 or 0.875, or maybe you used a 0.9. If you do that correctly, you get about 17.25 or 17.3, depending on how you rounded it. Now, next up, everybody listen up. Are you watching? All eyes up here. Heads up. All right, here we go. When will the balloon hit the ground? This is a question you haven't really been asked, but you should understand what you're being asked to find. When it goes up and it comes down, its height off the ground is 0. And my height is given by the model up at the top, negative 16t squared plus 28t plus 5. I want to know, when is that going to be 0? And we have multiple ways to solve this quadratic equation, but not all of them can work. I can't isolate the t by using square roots and just do some algebraic manipulation because I do have this term right here. It will not factor if you try to factor it. You'll have to use the quadratic formula. What do you have to use? Louder. What do you have to use? You have to use the quadratic formula. All right. What does the quadratic formula say you do? It says you do, and I'm not going to sing it. Ha, lucked out. But negative b plus or minus, I can't help myself, the square root of b squared minus 4ac all over 2a. There it is. And what do? I plug this stuff in. Opposite of b plus or minus the square root. I need to go do b squared on my calculator when b is 28. So I need to take care of doing a 28 squared. We'll do that in a little bit. Minus 4 times a times c. What are those? Go back up to your model. We've got a being negative 16. We've got a B of 28 and a C of 5. All right, so negative 16 times 5 all over 2A, which is negative 32. Then you need to go to your calculator to take care of what's under this root. If you haven't yet, I suggest you go do it right now. And when you do that correctly under there, the entire chunk under the root ends up being 1,104. But I would like for this video to get paused and maybe you guys actually go do that on your calculator to make sure you can come up with a 1,104 into there. Maybe you're going to square this first, and then I don't care however you crank that thing out, but make sure it's right. All right, what do we do next with our quadratic formula? We have to go take this root, and we're going to round it, let's say, to the tenths. Maybe you'd rounded it differently, but we are going to have negative 28 plus or minus, if you round that to the tenths, so make sure you know how to work your calculator, all over negative 32. At this point, we branch off. We add it and we subtract it. But I'm going to tell you this branch I don't really need to do because it's going to send me to a negative answer, which for time does not make sense. So I need to do negative 28 plus 33.2. All divided by negative 32. And again, you take out your calculators, but the correct answer for this was about 1.9 or 1.91, depending on your rounding. And this one sends you to a negative answer, which is impossible. We're not going back in time. So that one is now done. Next page, moving right along. And that one would be worth, I suppose we should maybe be keeping track of points, although it doesn't really matter. But I would have given for this one, I would have given, where's the rest of the problem? 3 for part A. I would give 2 for part B. 1 for showing me you're plugging it in, 1 for actually doing it correctly. And I'd probably give about 3 points for this one. Even though it's a lot of work, I wouldn't make it super heavy on the grading. So then, next up, I've got to go to the next page, and let's go. Cruising right along here. This is getting long. Phew, I'm getting thirsty. I'm getting tired too. All right, so here we go. Next one up is solving. We will tell you how to solve it, so you shouldn't be debating what method to use in this class. That's in another one. When it says by square roots, we just isolate that x. We just use pure algebra. To undo a square, we take a square root. We can't lose the plus or minus though, because 6 is times 6 equals 36, so does negative 6 times negative 6. So make sure you remember that plus or minus every year. About 5 people forget it. Number 13, direct attack, pure algebra. X squared equals negative 7. X would equal the square root of, the minute I go like that, I stop and I say no solutions because we can't root negatives. Keep in mind, I'm picking up the pace because you should be better at this page. It's more recent. For number 14, I'm going to add that 75 onto both sides. I'm going to have 3x squared equals 75. Should have divided by 3. Each step is a point, so make sure you're showing me the work. Don't just plop down a 6. All right. What, when I square it, gives me 25? 5 does, sure. But I'm going to give you a, that was empty set or no solution. Don't put a 0 there, by the way. That's an empty set symbol. Make sure you put that plus or minus on there. Point allotments. Number 12 would be worth 2. Number 13, worth 2. Number 14, worth 3. Number 15, it says factor it. So we're going to factor it. What multiplies to equal negative 12 that I can get a 1 out of? That would be a 4 and a negative 3. If you left this, you're going to take 2 points off because if 2 things multiply to equal 0, one of them's got to be 0. So either this chunk is 0 or this chunk. What makes each piece 0? A negative 4, or the answer could be 3. We've got two answers to the problem. Negative 4 works and 3 would work. Again, if you just left it at the factoring stage, you're going to have to take 2 off. So 1 point for each factor, 1 point for each answer. In order to factor it, we got to get the sucker equal to 0, so let's subtract 18. Wake up! All right, here we go. We are going to factor it. I'm going to see that a 9 and a 2 are my winning pair of numbers. If I quit here, I've got to take 2 points off. You get a point for each factor, a point for each answer. If you leave it blank, you are out 4. So 2 answers to this one. 9 would make it 0 and a negative 2 would make it 0. Number 17, x squared equals 5x. I got to get it equal to 0. Then I've got to factor it. I can see that there's an x living in both of these, so I will pull it out. Again, 2 factors, 2 answers. What's one of the answers? When x is 0. The other answer is when x is 5. So we've got 2 answers. Each of these I'd probably make worth 4. Or if I made them worth 3, I'd take 1.5 off. If you half the points, though, it's for getting the answers. You might want to circle this several times. When it says solve, I want some answers. Number 18, I kind of go, oh, crap, because it's that kind where you have to find your winning pair. Well, let's go do it. What could give me an 8? And there's lots of options. The first thing that pops into my head is 4 and 2 and 5 and 3. If I can't get those to work, well, and I'll try 15 and 1, 4 and 1, but let's give this a shot first. What do I mean by get it to work? Try to create that negative 14. Can I do it out of 20 and 6? Why, yes, I can. Score! 1 for Leroux. All right. So I can as long as the 20 is negative. So run a double check on that when you've got your selection. Do these multiply to equal negative 15? Why, yes, they do. Do these add up to negative 14? Yes, they do. So now I'm super excited because I can factor it. I've got a 4x and I've got a 2x. I've got my 4 linked to a minus 5, and then I have a plus 3. Well, how could you check that, Mrs. Leroux? You could FOIL it, but I'm not going to because I know it's right. But now I've got 2 answers. What makes it equal to 0? Don't make the mistake of saying negative 3 and positive 5. Everybody listen to me. You have to either physically set it equal to 0 and solve it, or you have to do the opposite of both operations, which means you'd have to subtract 3 and divide by 4. On this one, you'd have to add 5 and divide by 2. No, you don't need that little plus sign in there. I'll take it off so it doesn't mess with your head. Oopsie. All right, so be careful with that if you're using any kind of a shortcut. So 5 halves and negative 3 fourths would be the correct answer. Next one says, what's the quadratic formula? Do I get to sing again? I'm super excited. I want to sing. But Daddy, I just want to sing. Here we go. Are you ready? X equals negative b, and I drew it wrong because my smartboard's being stupid. Negative b plus or minus the square root of b squared minus 4ac all over 2a. There it is. Let's begin. We're at the very end. We are nearing the end, my friends. You're hanging in there. Thanks for being so wonderful. Quadratic formula. Here we go. A is 3. B, I can't see it, but it's there. It's a 1. C is a negative 2. Now I plug them into my formula, which says I do the opposite of B, plus or minus the square root. B squared is 1 times 1, minus 4 times A times C, all over 2 times A, not 2. 2 times A, which is 6. Then what do? I go under this root and I take care of it. And when I do, I get a 25. It's really 1 minus negative 24. So I get negative 1 plus or minus the square root of 25 all over 6. Do I know the square root of 25? Why, yes, I do. So no need to go to my calculator. All right. Then what do? I go up and I go down. Negative 1 plus 5 is a 4. I need to divide it by 6. Why 6? Because it's all over 2a. Negative 6 over 6. Don't leave that. I like them as fractions. If you wrote a decimal, if you wrote 0.6 repeated for that, I would give you full credit. But I like fractions are our friends, decimals are the devil. Number 21, here we go. Got to get it equal to 0. That's a key important part, or the sign of C will be off. So make sure A is a 1. Bam. B is a 6. C is not 16 because when I bring it over to its proper place, it's a negative 16. And here I go again. X equals the opposite, or negative B, plus or minus the square root. 6 squared is 36. Minus 4 times A times C, all over 2 times A. Bam. Under that root is 100. You'll have to do that on your calculator in your head. It's a 36 minus a negative 64, which makes us add it. We get plus or minus the square root of 100. Do we know the square root of 100? I do. It's 10. So I get negative 6 plus or minus 10 all over 2. I branch up, I branch down. I add, I subtract. Negative 6 up 10 launches me at a 4. 4 over 2 is 2. Lovely, pretty answer. The other one, if I go down 10, negative 6 down 10 sends me to negative 16. Cut it in half. I get an 8. All right, so you should have a 2 and a negative 8. These would be worth about 4 or 5 points each. We're just not going to keep track of the score anymore. All right, am I equal to 0? Yes, lovely. Let's begin. A is 2, B is negative 4, C is 8. Let's have at it. X equals negative B. Be careful with that because B is already negative. So the opposite of B would make it positive. So X would equal 4 plus or minus the square root. Don't square it on your calculator. What did I say? Square it in your head. Negative 4 times negative 4 is 16. That first thing you write under the root better be positive. If it's not, you're not listening to me. If you pick anything, it's got to be positive right there. Anyway, B squared minus 4AC all over 2 times A, which would be 2 times 2. You could put a 4 down there. We go do this on our calculator, and it ends up being negative. We can't root negatives. So I don't even care what's under there. I know 4 times 2 is 8 times 8 is 64, and when I subtract 64 from 16, I go negative. So we stop right here and we say no solutions, or we could put the empty set symbol, but I'm going to write no solutions. Make sure you don't put a 0 if you're using that empty set solution. It's got to look like this. All right, number 23. Here we go. It'd be x squared minus 10x plus 25 equals 0. We must have it equal to 0. A is a 1, B is a negative 10, C is a 25, and so we begin again. This is so fun. X equals negative B, the opposite of B, and it is negative, plus or minus the square root of B squared. Square it in your head. Negative times a negative gives you a positive. You should always have a positive lead. Minus 4 times A times C all over 2 times 1, or 2A. Under here is 100 minus 100, which is 0. Does that mean we're done, Mrs. LaRue? No, it doesn't. I do know the square root of 0. It's 0. So I've got 10 plus or minus 0 over 2. Now are we done, Miss LaRue? Almost. We go up 2 and get up 0 and get a 10 over 2. But when we go down 0, we get the same thing. So I'm getting the same answer twice, and that answer is 5, and I need to only write it one time. Done. How's that? Pretty good, right? So last page. Are you ready? Last page. Here we go. When you solve a quadratic equation, which we just did a bunch of times, what does the solution represent on a graph? It represents where it hits the x-axis. It could hit twice, it could hit once, it perhaps never hits and we write no solution, but it gives us those x-intercepts on the graph. Bam, 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 bam. And now the easy part. Linear, quadratic, or exponential. 25 makes a line. 26 gives me that exponential curve. 27 is a parabola. which is a quadratic function. Those are just going to be worth 1, 1, 1, because it's pretty easy stuff. Now on number 28, 29, and 30, we need to plot and decide what we've got going here. So I'm going to move my grids a little bit off here so you can see them. Number 28, let's go plot those points. 2 to the left, 11 down. 1 to the left, 6 down. 0 to the left, 3 down. 1 to the right. Sorry, I'm going to write this a little nicer here. 1 to the right, 2 down. I just erased half of it. Sorry, I'll get this going nicer here. -1, -6 is right there. 0, -3 is right here. 1, -2 is right here. 2, -3 is here. And then I'm back at -6, and it went up, it peaked out, and it came down, giving me a quadratic function and a parabolic graph. Number 29. I'm so excited because I'm almost done. So close I can taste it. I'm at -2, 7. So let's go to the left. 1, 2, 3, 4, 5, 6, 7 up. Let's go -1 to the right and 5 up. -1, 1, 2, 3, 4, 5. It's hard to see on this grid. My eyes are getting a little batty here. 0, 3, 1, 1. 2, -1, 3, boy, that looks an awful lot like a linear function. Last one, -2 and 1/4. Well, I'm barely off the grid there. -1 and 1/2. I'm just kind of creeping along here. 0, 1. 2, 4. Well, that's going up awfully quickly, and that's called exponential growth. So exponential, we are done. Phew. Now, what if you didn't do very well? You should study it. Miss Dutzman and or Mr. Nelson are going to give you the quizzes back. I don't know that they're going to have time to go over the whole thing, but they should definitely hit what they think you guys need the most work on. All right, so test is tomorrow. Peace out, Girl Scout.